So since they want the 95% confidence level, so you put CL is equal to 95%. So the next thing that they ask us or they tell us, they say that they want our estimate to be within 20% of the true value of sigma. So we're going to say our margin of error should be 20% from sigma. Everybody good so far on that? So for these type of problems, you actually don't need to do any mathematics. There's actually a table, and I'll post that table where I put the t-table and the chi-square table. So all you have to do, you have to look at the table. So right now, what we're looking for something that says confidence level of 95%. We want it to be margin of error of 20%. And we want it to be for standard deviation. So I'm gonna go to the table right now. All right, so for the table, we're looking for three things. We're looking for a confidence level of 95%. We're looking for if for sigma, and then we're gonna be looking for within 20%. So if you look at the first thing, we want it to be for sigma. So if you look on top, this one says sigma, this says sigma square. So that means we're not going to use this side of the table. So that means we're going to use the left-hand side of the table. So the next thing what you want to do, you want to look at confidence level. If you look at it, it's telling us we want 95% confidence level. So if you look at the table right here, it says to be 95% confident that S is within. So that's at 95%. If you look at this one, this says 99%. So since this one says 99%, I'm not going to use this one because we want it to be confidence level of 95%. So then what we want to do, we want to see what do we want it to be within. So since we said we want it to be within 20%, all right, here, let me. So since we said we want it to be within 20%, 20% is here. And if you look at what's right across from it is the 48. So for this one, we'll say N has to be at least, we'll say N is at least 48. And that's it for that one. So once again, for this one, I'll post the table on Canvas. Just go to the where I put the table for the t-table and the chi-square table, and I'll put it right there. All right. But any question for this problem? All right, and that's it for chapter 7. So we'll say N is equal to 48. All right, any question in regard to chapter 7? All right, so up next we're gonna go to chapter 8. So for chapter 8 is gonna be the beginning of hypothesis testing. So for this one, the first section or the first part of it is very heavy vocab. So you kind of want to pay attention to the key vocabulary word because there could be a bunch of them. So let's go ahead and let's get started. All right. So for chapter 7, the name of the table, I don't know if it has a name. Oh, you put finding sample size. Oh, you name it there. Finding sample size for sigma. So just look for a file that says finding sample size for sigma, and it should be there. Let's see if I can do that. So we're gonna start with chapter 8. So chapter 8, we're talking about hypothesis testing. So this is pretty much what a statistic is, because pretty much in statistic, you're always gonna have a hypothesis. And what you're trying to do, you're trying to prove that that hypothesis is correct. So usually when we're doing hypothesis testing, we're usually gonna have two hypotheses. So one of the hypotheses is going to be called the null hypothesis, and the notation for the null hypothesis is HO. And then we're going to have the alternate hypothesis, which is H1. All right. So one thing you kind of have to just know, for the null hypothesis is always what we think is already true. So the null hypothesis will be what we already think is true. The alternate hypothesis, we're trying to prove that the null hypothesis is not true anymore. So kind of think about it, say like I'm trying to prove that the sky is red. So the null hypothesis will be what we think the sky color is so far. So the null hypothesis will be, oops, don't want to do that. The null hypothesis will be sky is blue. So the null hypothesis will be the default. Whatever we think should be true, well, the null hypothesis, we're going to state that it is. So the null hypothesis is always the default. It's always the status quo. Whatever it used to be, we're going to still assume it's still that. For the alternate hypothesis is what we're trying to prove. So we're trying to prove that this sky is red. So that's how the hypothesis is going to work. The null hypothesis, HO, will be the status quo, what we think it still is. The alternate hypothesis is going to be what we think it is now. So it's going to be what we're trying to prove. Right. Any question in regard to the null hypothesis or the alternate hypothesis? All right. All right. So this is essentially going to be how we're going to be doing this for chapter 8. So for chapter 8, this is pretty much the step we're going to be doing when we're doing hypothesis testing. So part number 1 is we make a statement regarding the nature of the population. So when we make a statement, we're just coming up with a hypothesis, and we're going to come up with a null hypothesis and the alternate hypothesis. Step number 2 is that collect evidence, sample data to test a statement. So we're actually not going to do step number 2 because for us, our data set will already be collected for us. So we don't have to collect anything. Step number 3 is to analyze the data to assess the probability of the statement. So once we have the data, we're going to kind of see how likely or how unlikely an event is of occurring. And step number 4, we're going to make a conclusion about the null hypothesis. So we're either going to say the null hypothesis is still correct or that the alternate hypothesis is not correct. So that's going to be kind of like the layout that we're going to be doing for chapter 8. So let's move down to page number 2. All right, let me see. I think my screen froze. Let's do this. All right. So pretty much what we're gonna do next is kind of lay out what's gonna be happening for the next several sections. Because this is pretty much gonna be the same thing like confidence interval. Well, where for confidence interval for like say 7.1, we did confidence interval for proportion. And then 7.2, we did confidence interval for the mean. And then 7.3, which was this last section that we just went over, we did confidence interval for standard deviation. So same thing is gonna happen for chapter 8. Chapter 8 is all gonna have to do about making a hypothesis test. The only thing different is what type of parameter are we testing? So in 8.1, we're gonna be testing population proportion. When we get to 8.2, we're gonna be testing the mean. And finally, once we get to 8.3, we're gonna be testing the, what do you call it, population standard deviation. So whenever we're talking about parameters, we're talking about these three parameters. We're either gonna be testing out P, testing out mu, or testing sigma. All right. Any question in regard to that so far? Ooh, cool. You have a question? No. No question. All right, perfect. All right, so up next we're gonna get into the null alternate hypothesis. So whenever I say parameter, that means we're gonna say HO is P, and then we're gonna say it's equal to some number. And whatever that number is that we think it is, you set it equal to that. So that's for proportion, but if we're doing it for the mean, you say mu is equal to some number. Or if we're doing this for standard deviation, you say sigma is equal to some number. So that's how the null hypothesis is always going to be. The null hypothesis is always going to be equal, because we're always going to give the benefit of the doubt to the value that we think it was. So say like if I'm flipping a coin, oops. Say if I'm flipping a coin, we're gonna give the benefit of the doubt that the coin is fair. So we'll put that P is equal to 50%. All right. So that's the null hypothesis. So for the null hypothesis, the inequality in the middle should always be equal. Any questions for the null hypothesis? All right, let's do the alternate hypothesis. So the alternate hypothesis, that's where you're trying to prove that something is actually occurring. So that's where we're trying to say, we don't think the value that used to be is still that value. We actually think it's different. So for the alternate hypothesis, we actually had three symbols that we could choose from. So we have not equal to. We also have less than. We also have greater than. So depending on what we're trying to prove, we're going to choose one of those three options. So let's kind of dig in right now and let's kind of focus on not equal to. So yeah, it froze, but it should be better now. Like, everybody see this hash mark or a hashtag? Oh, all right. Yeah, for some reason it's just lagging today. All right. So whenever we say not equal to, usually we're trying to prove that whatever that value is, we're trying to prove it's not that value. So say like if we're flipping a coin and the coin we're gonna say is 50% head, 50% tail. If I wanted to just prove that it's not 50%, I would put not equal to, because for not equal to, it just means we don't think it's 50%. It could be bigger than 50%, or it could be smaller than 50%. I don't really care. I just care that it's not equal to 50%. So that's when you want to use not equal to, and usually they call this a two-tailed test. Everybody good for not equal to? All right. So up next, we're getting into less than. So less than is over here. So less than, kind of the key word that you want to look for less than is less, smaller, decrease. Because all of these words are kind of telling us that we don't think that it's 50%. So going back to P is equal to 50%. If we think that it's less than 50%, or smaller than 50%, or that it has decreased from 50%, that's when you want to use this symbol over here when it says less than. And usually they call this a left tail test. So if you look right here, left tail. And the reason why they call it a left tail test, because the left side is shaded. Any question in regard to a left tail test? All right, so let's get to the last one. So the last one is this symbol over here, which means greater than. So keyword to look for here is greater than, bigger, or increase. So anytime they say that we think it's greater than, bigger, or increase, that's when you want to use that in inequality. So those are kind of like the keyword that you want to look for to make sure that you want to use that inequality. So those are the three symbols that we're going to use for the alternate hypothesis. We could either say not equal to, less than, or greater than. Any question in regard to those three inequality? All right, perfect. So let's scroll on down. All right, so up next we're gonna go into and we're gonna create a null hypothesis and alternate hypothesis for the next three problems. So these are the three problems we're gonna be working on. So we're gonna come up with the null hypothesis and the alternate hypothesis. So we're coming with HO and H1, HO. Here, this is the HO, H1, HO, H1. All right. So anytime you're reading these type of problems, the first thing you want to do is first figure out which parameter are we using. So when I'm talking about parameter, it's going to either be P, it's going to be mu, or it's going to be sigma. So when I ask you which parameter do you think it is, you're going to tell me one of those three. All right, so let's do this first one. So for that first one, it said in 2008, 62% of American adults regularly volunteer their time for charity work. A research believes that this percentage is different today. Okay, so which parameter do we think it is? Do we think is P? If you think it's P, put A. Do you think it's mu, put B, or do you think it's sigma, so put C? So put your answer on the chat. All right, so far we have one person or two person. All right, so we have 2% out of 12. All right, cool. So I got mostly everybody for B. So B is not the right answer. If you look at it, anywhere in the problem do they talk about the mean? Like nowhere in the first problem do they talk about the mean. Like what are they talking about? Am I reading this wrong? Okay, let's look at the thing. So if you look at it, do anywhere in the problem do they say standard deviation? Like, let me highlight the problem I'm looking at. Maybe you're looking at a different one. Why is this lagging? All right. So if you're looking at the problem, like nowhere in the problem did it ask us about standard deviation. Nowhere in the problem did it ask us about the mean. Like if you actually read the problem, it's talking about percentage. So what is percentage? Well, that's P over here. So that means our parameter is P. All right. So what was the last known percentage of American adults who regularly volunteer for charity work? Yeah, 62. So we're gonna say P is equal to 0.62, P 0.62. So, all right, so if you look at it, we put P is equal to 0.62 because that's the last known percentage that we have. So we're going to assume that's correct. So that's our claim. So our null hypothesis will be that the percentage of American adults who regularly volunteer is still 62%. But what are they trying to prove? So here, let's do this. So if you want to put this symbol, let's say, I don't know, N. If you want to put this symbol, press M. If you want to press this symbol, let's press, I don't know, P. So which symbol should I put for in between P and 0.62 for the alternate hypothesis? All right, so we have one for P. So if you look at it, you do want to put not equal to, because if you look at right above it, it says different. So anytime there's a difference, we don't care if it's higher than 62% or lower than 62%. We care if it's different, so that's when you put not equal to. Okay, so that's the null hypothesis, and that's the alternate hypothesis for this one. Any question for that first problem? All right, so let's go on to the second problem. So second problem, I'm gonna highlight it in pink. So that way I know for sure we're looking at the same thing. All right, so if you look at the second problem, it says, according to a study published in March 2016, the mean mile per the gallon for a hybrid car is 50. A researcher believes that the mean mile per the gallon has increased since then. All right, so for this one, which parameter am I testing? Cool, yeah. All right, good. So yeah, so it should be mu. So we put mu right here. And if you look at it, it says the mean. So since it says the mean, that's why I know is mu. All right, good. All right. So what do they believe the mean mile per the gallon for a hybrid car is? Yeah, 50. So we put 50 right here. We'll put 50 right here. So just know for the null hypothesis, you always put equal. All right. Everybody good so far on the null hypothesis is mu is equal to 50, and then the alternate hypothesis is mu and 50. All right, so which symbol should I put in between the two values? So should it be greater than, less than, or not equal to? Cool. Greater than, so n. All right, so if you look right here, the keyword here is increase. Since it said increase, you want to put mu is greater than 50. Because mu greater than 50 mean it should be bigger than 50 or it should be increased from 50. And that's it for that second one. All right, any question in regard to the second one? All right, so let's do this last one. It says that using an old manufacturing process, the standard deviation of the amount of wine put in a bottle was 0.23 ounces. With a new equipment, the quality control manager believes the standard deviation has decreased. All right, so let's try this again. Which parameter are we testing? P, mu, or sigma? Cool, finally. All right, so you put sigma. Because if you look at it, they say they believe the standard deviation has decreased. So you do want to put standard deviation. Any question on why we choose standard deviation? All right, so what do we believe the standard deviation should be? Yeah, 0.23. So we'll put sigma equal to 0.23, 0.23. All right, some of you already gave me the answer for which symbol should we use. So you want to put less than. Just decrease. All right, and that's it for that one. So that's how you come up with your null hypothesis and your standard deviation. Well, sorry, your null hypothesis and your alternate hypothesis. So first thing you want to always look for, which parameter are you testing? Once you figure out which parameter are you testing, then you want to go ahead and just see, are we testing to see if it's the same, if it's greater than, less than, or not equal to. Okay. Any question in regard to that? All right. So up next, we're gonna go ahead and we're gonna talk about errors. So there's different type of error that we come up with. So the different type of error are you talking about that we came up with the wrong conclusion? So say going back to that problem about the sky is blue and I'm trying to prove that the sky is red. So one type of error could be that I could say the sky is, so I could conclude that the sky is red, but in actuality, the sky is actually blue. So that's me coming up with the wrong conclusion. Because sometimes the thing is, we're going to come up with the wrong conclusion because since this is a sample, sometimes our sample is not the best sample and it might lead us to the wrong conclusion. So we're going to go over two different type of error. One of them is called a type 1 error, which the symbol for a type 1 error is alpha. And there's also something called a type 2 error, which the symbol for a type 2 error is beta. So here's the type 1 error. Here is the type 2 error. So just remember, anytime we're talking about error, you could either come up with a type 1 error, which is alpha, or a type 2 error, which is beta. But just know, whenever we say we came up with an error means we came up with the wrong decision. So wrong decision just means that we concluded the wrong thing when the opposite was actually the correct answer. And kind of going back to the problem about the sky, so an error will be me saying the sky is actually red, when in fact the sky is actually blue. Everybody kind of good so far with type 1 and type 2 error? So wait. No, the pretty much alpha and beta are two different type of error. So when we say we did a type 1 error or type 2 error, it just means we came up with the wrong conclusion, but there's different type of error that we can make. All right, so let's kind of go into what is alpha and what is beta, or a type 1 and a type 2 error. So a type 1 error is when we reject the null hypothesis when the null hypothesis is true. So when we say reject the null hypothesis, rejecting the null hypothesis means I came up with the conclusion the alternative hypothesis is correct. So for this one, we'll say, no. So we say HO is true when, oh sorry, I should say H1. So when we talk about type 1 error means we conclude the alternative hypothesis is correct, but the null hypothesis was actually true. And that's kind of the example that you gave about the sky. So a type 1 error in that case scenario would be I'm saying the sky is red, but in actuality the sky is blue. So that's a type 1 error. Any question in regard to a type 1 error? All right. So a type 2 error, which is beta, a type 2 error is when we say the null hypothesis is correct, but the alternative hypothesis is actually true. So in this case scenario, it will be, so still using the sky is blue example, it will be me saying the sky is blue, but in actuality, the sky is actually red. So that will be a type 2 error when you conclude the null hypothesis is correct, but in fact, the alternative hypothesis was true. So you kind of remember this is just saying like we made a mistake. So our conclusion was the wrong conclusion. We should have done the other conclusion. All right. So also just kind of know whenever we talk about type 1 error, a type 1 error is also called the level of significance. So if you ever hear me talking about like alpha or talking about type 1 error or talking about level of significance, just know all of them are the same. So I'm talking about the same thing. So let's scroll down. Actually, before we do this example, let's do this example. So the next example we're gonna do an example of the court system. So So maybe some of you had gone to court. So when you go to court, what are the two options that could happen? The judge could either find you what? Cool. All right, so we have innocent or guilty. But if you kind of notice in the justice system, they kind of never tell you you're innocent. They just say you're not guilty. So we'll go for guilty and not guilty. Okay, so let's kind of figure out which one will be the null hypothesis. Which one should be the alternate hypothesis? So when you go into court, what is the default position? Or the default position that you're guilty or the default position that you're not guilty? All right, so what's the default position? Well, like, what should they automatically, like, when you go into court, are you automatically assumed to be guilty or are you automatically assumed to be not guilty?
Not guilty until proven innocent.
Yeah, so pretty much the null hypothesis should be you're not guilty. So that means the alternate hypothesis is you're guilty. Okay, if you kind of think about it, you need to have evidence in order to prove. Why is this not working? Right. So the null hypothesis should be that a person is not guilty because as soon as you enter to the courtroom, pretty much is innocent until proven guilty. They need to have evidence in order to prove that you're guilty. So that way the alternate hypothesis should be that you're guilty. Right. Everybody kind of go with that idea that the null hypothesis is that you're not guilty. The alternate hypothesis is that you're guilty. All right, perfect. All right, so this is what I have here. So I have here the jury. So this is what the jury come up with. So the jury, they're gonna say this person is not guilty or this person is guilty. If you look on the top, I have the truth. So this means that we actually know that person is actually guilty or that person is actually not guilty. So kind of think about it, at the end of the trial, the person will actually tell us if they were actually guilty or not guilty of that crime. So they're being honest with us. So right here we're gonna say HO is that they're not guilty. Right here we'll put H1, they're guilty. HO, not guilty. H1, they're guilty. Cool. All right. So the rows are what the jury came up with. So the jury either came up with that the person is not guilty or the person is guilty. The truth is pretty much the person at the end of the trial tell us the actual truth, that tell us, hey, I was guilty or that he wasn't guilty. All right. So what we're gonna do, we're gonna fill out this box and we're gonna decide if they came up with the right decision or if they came up with the wrong decision. So right now, all we're looking for is if it was the right decision or a wrong decision. Once we figure out if it's a wrong decision, we're gonna try to figure out if it's a type 1 error or a type 2 error. So let's go ahead and we're gonna first focus on this box right here. All right. So for this box, if you look at it, under the row is under that the jury said the person is not guilty and the truth is the person is not guilty. So if the jury said the person was not guilty and the truth is the person was not guilty, did they come up with the right decision or with the wrong decision?
Right?
Yeah, right. So we'll put right. Perfect. All right, so that's that box. So let's do this box now. All right, so for this next box, what we want to do, if you look at it, is the jury said the person is guilty, but the truth is the person is not guilty. In this case scenario, did they come up with the right decision or a wrong decision?
Wrong?
Yeah, good. Look, wrong. So we'll put wrong over here. Right. So let's do this next box over here. So for that box is the jury said they're not guilty and the truth is they're guilty. So did they come up with the wrong decision or a right decision?
Wrong?
Yeah, so wrong. So we'll put wrong. And let's do this last one over here. All right, so if the jury said they're guilty, but the truth is they're guilty, did they come with the right decision or wrong decision? Cool, so right. All right, so when we're coming up with a conclusion, these are the type of decision that we can make. So some of the decision at the end of the day, we came up with the right decision, but there are going to be some time when we come up with a wrong decision because not every time we're going to be able to come up with the right decision because we're not going to be 100% accurate because we're using a sample versus actually using the entire population. So when we talk about type 1 and a type 2 error, so we're talking about these. So we already know we made the wrong decision, but there are different type of wrong decision that we can make. So there could be a type 1 error, which is your alpha, and there's a type 2 error, which is your beta. So right now what we're gonna do, we're gonna try to figure out which of these wrong decision, which one is a type 1 error, and which one's a type 2 error. So for a type 1 error, is when you reject HO when HO is correct. Beta, which is a type 2 error, is when you so a type 1 error is when we reject the null hypothesis when the null hypothesis is correct. A type 2 error, which is beta, is when we fail to reject HO. When we say fail to reject HO, that means that we say HO is correct when H1 is correct. So let's look at this one. So what we want to do, we want to decide if this wrong decision, was it a type 1 error or was it a type 2 error? So which one do you think this wrong decision is? Do you think it's a type 1 error or a type 2 error? All right, cool. Time is up. All right, so we got one that says alpha. So that's actually correct. Good. So this is actually all right, let me do this. Let's reshare. All right. So this is actually a type 1 error because a type 1 error is pretty much, if you kind of think about it, is when you send an innocent person to jail because you reject the fact that they're innocent and you say they're guilty, but in actuality, they're actually innocent. So when we talk about type 1 error in this case scenario, it's when you send an innocent person to jail. All right, so that's your type 1 error. Any question for type 1 error? All right. So if this is a type 1 error, that means this one should be a type 2 error. So a type 2 error, what a type 2 error is, beta, yeah, good, beta. A type 2 error is when you send a guilty person and you set them free. So they actually are guilty of the crime that we're saying they're guilty of or convicting them of, but we actually say they're innocent. So that's what a type 2 error will be in this case scenario. It will be setting a guilty person and setting them free because they are guilty, but we weren't able to prove that they're guilty. So, all right, so that's a type 1 and a type 2 error. Any question in regard to the type 1 and type 2 error in regard to this problem? So let's get into how do the type 1 and type 2 error, like how do they relate to each other? So I'm going to put a type 1 error and a type 2 error. So which of the two error do you think is worse? Do you think it's worse that I send an innocent person to jail? Or do you think I send a guilty person and set them free? Which one do you think is more, well, which one do you think is worse? Me sending an innocent person to jail or a guilty person being free?
A guilty person being free.
So you think it's worse to send a guilty person being free? All right, cool. All right. So say I'm very paranoid. I don't want any guilty people going on free. So say I want to reduce the chances of this happening. So say I'm very paranoid letting one guilty person free. So if I'm very paranoid about letting one guilty person go free, like what can I do to stop that from happening? So can I imagine if you're in the jury? So if you're in the jury, like how can I prevent me sending a guilty person and sending them free? Like what can I do in order to prevent that from happening? Well, you can't really find any evidence because if you're in the jury, you're pretty much just there and they're presenting you the information. Yeah. So yeah, good. So pretty much you send everybody to jail. So anybody who give you like a bad look, give you a wrong side eye, you're gonna send them to jail. So that's how I could prevent pretty much doing a type 2 error. So anybody who look at you wrong, pretty much you send them to jail. So what's that's gonna happen with my type 1 error? If I'm sending everybody to jail who look at me wrong, what's gonna happen with my type 1 error? Is that gonna go up or is that gonna go down? Cool. Yeah, so it should go up. Nah, let me reshare this. So this is actually gonna go up because since I'm so paranoid of letting one guilty person out free, I'm gonna send everybody to jail. And when I'm sending everybody to jail, pretty much there are gonna be some people who are actually innocent that I'm sending to jail. So if I'm paranoid about making a type 2 error, I could lower the percentage of making a type 2 error. But yes, no, if you lower the percentage of making a type 2 error, it's going to increase the chances of me making a type 1 error. So let's go ahead and let's do the opposite now. So say I'm very paranoid of making a type 1 error. So let's do a different color. So let's say I want to get the probability of making a type 1 error and I want to lower it. So I don't want to send an innocent person to jail. So if I don't want to send an innocent person to jail, as a jury, what am I going to do now if I don't want to send an innocent person to jail? So if I don't want to send an innocent person to jail, is that going to make it where I'm convicting more people of being guilty, or am I going to be pretty much, or am I going to not convict that many people of being guilty now? Like, what should happen if I'm afraid of making a type 1 error? Am I going to be convicting more people, or am I going to convict less people? Cool. So you're going to convict less people. Good. So if we're going to be convicting less people, that means the chances of me making a type 2 error would now go up. Because if now I'm very afraid to send anybody to jail, I had to kind of realize that the chances of me now sending a guilty person and sending them free is going to get higher, because now, since I'm so paranoid and making a type 1 error of sending an innocent person to jail, I'm not going to want to send anybody to jail. So now there are going to be more people that I don't send to jail that might have been considered guilty. So just know, if one of the percentage goes up, the other percentage should go down, or vice versa. If type 2 error goes up, type 1 error will go down. Any question in regard to that? Sweet. All right, so let's go ahead and do this one. So we're gonna go ahead and do this problem. So the problem is whether a person is pregnant or a person is not pregnant. So what should be the null hypothesis? Should I assume everybody's pregnant, or should I assume that nobody's pregnant? Like, should you go around to everybody going like, hey, are you pregnant? Hey, are you pregnant? Or should I just assume more likely than not, a person might be not pregnant? Cool. All right. So we're going to say the null hypothesis is the person is not pregnant, which will be smart. So we're going to assume everybody is not pregnant. So that means the alternate hypothesis is a person is pregnant. All right. So what type of evidence would I need in order for me to assume somebody is pregnant? What do you mean by plan B? All right, cool. So one of the ways we can know if they're pregnant is they take a pregnancy test. But say if I just want to go by looking at them, just by looking at them, how can I tell if they're pregnant?
By their body.
Yeah, by their body, but more importantly, like Alondra said, by their belly. Cause you kind of want to see if they have a baby. So if they have a belly, more likely than not, they might be considered pregnant. If they don't have a belly, more likely than not, they're probably not pregnant. So that's how you could tell if somebody is pregnant or not pregnant. So let's look at this first scenario over here. So the doctor telling them, hey, you're pregnant. So the doctor telling you, you are pregnant. What is going on? All right, so the doctor told this person, hey, you're pregnant. Do you think this person is pregnant? That's a good arrow. Okay. Yeah, so more likely than not, this person is not pregnant. So you're pregnant, but you are really not pregnant. All right. Yeah, he's a male, so more likely than not, he's not pregnant. So in this case scenario, did the doctor come up with the right conclusion? So when the doctor told this guy, hey, you're pregnant, did he come up with the right conclusion? Or did he come up with the wrong conclusion? Well, if you look at it, he came up with the wrong conclusion. Cool. So he came up with the wrong conclusion. So let's look at this doctor over here. So this doctor over here telling this female she is not pregnant. But by the way the female looked, does the female look pregnant or does she not look pregnant? Yeah, so she looked pregnant. So in this case scenario, did the doctor come up with the right conclusion or the wrong conclusion? So the doctor told her, you're not pregnant, but you told me she was pregnant. And yeah. Yeah, so for this one, it should be a wrong conclusion. So if you look at it, both of these are a wrong conclusion, but they're different type of wrong. So what we want to do, we want to see which one is a type 1 error, which one is a type 2 error. So which one would be a type 1 error? So would it be the male or would it be the female? Well, for this one, the type 1 error will actually be the male. In the male, we reject the null hypothesis because the doctor concluded that the male was pregnant when the male was actually not pregnant. So just by going strictly on the definition of type 1 error, if you conclude the alternate hypothesis when the null hypothesis is true, that's a type 1 error. So that means this one will be a type 2 error. Because for this one, they don't reject the null hypothesis. They conclude the null hypothesis is true, but the alternate hypothesis was actually true. All right. And also, if you just look at the problem, I straight up tell you, the first one is a type 1 error. Second one is a type 2 error. And that's it in regard to that. Any question in regard to the last problem? All right, so let's do this next problem. Well, actually, let's skip this one. Let's just go to this one. So this one's multiple choice. So you can either say we made the correct decision, we made a type 1 error, we made a type 2 error, or none of the above. So for this problem, it says, suppose we conducted a hypothesis test on the average height of men and reject the null hypothesis. So the null hypothesis is that mu is equal to 66. If the true average height of the population of men is 69, what can be said about our decision to reject the null hypothesis? So the null hypothesis is that the average height of men is 66. But if you look at it, it said we reject the null hypothesis. So if I reject the null hypothesis, I'm saying this is not true. But later on, I found that the mu, or the average height of men, is 69. So did they come up with the right decision to reject that? So were their conclusions correct to reject the null hypothesis, or should have they not rejected the null hypothesis? So should they have rejected, or should have they not rejected? Cool, yeah. So if they should have rejected, which option should I say? A, B, C, or D? Cool. So you say A. So you say we made the correct decision because we rejected the fact that the men's height was 66 inches tall. And that was true because it actually turned out that the men's height was actually 69 inches tall. So we should have rejected, so we came up with the right conclusion. And that's it for that first one. Any question for that first one? All right, so let's do this next one. And then that'll be it for today. So for this one says, suppose we conducted a hypothesis test on the average salary of a single mother and reject the null hypothesis that HO mu is equal to 25,000. If the true average salary of a single mother is 25,000, what can be said about our conclusion for our hypothesis test? So the null hypothesis is that mu is equal to 25,000. But if you look right here, it said we rejected that. So say we don't think this is true. But later on, we actually find out that mu is in fact $25,000. So in this case scenario, did they come up with the right conclusion? Should they have rejected, or should have they failed to reject? Cool. All right. So Brianna says no. They should have not rejected. All right. So since we said no, it wasn't the correct decision, that means I know it's not A. So that means it has to be either B or C. All right. So to figure out, to see if it's B or C, if it's B, that means they reject the null hypothesis. If it's C, that means they fail to reject HO. All right. So what should I say is the answer? So A or B or C or D? No. Most of you already said this, so it's B. Because the fact that they rejected the null hypothesis, that's pretty much telling us that it's a type 1 error. Because if we already know they made a wrong decision, and I know they rejected the null hypothesis, that's pretty much telling me that is a type 1 error. And that's it for that one. Any question in regard to the last round? Cool. All right, so we're gonna stop over here because I don't know what's going on with the technology to keep on freezing. So we're gonna stop here and we'll continue on Monday in regard to that. Yeah, type 1 is alpha. Yeah. So yeah, so we'll continue on Monday. So if you still haven't done the test correction is due today at midnight. So you just have the test correction in by midnight, for that way you could get credit for them. Because if you turn it after midnight, you're not gonna get any credit for that. Yeah, so you want to just scan them in and then just upload it to that document for the test correction. It should say like test correction for test 2 or test 2 test correction, something like that. So you scan them and you just upload them into that document. All right. Any other questions? Cool. All right. So that's it for today. Everybody have a nice weekend. For all of you mother, happy Mother's Day. Hopefully it should be a fun Mother's Day. Yeah, you should have a quiz on Monday. And it'll be pretty much what we cover on Monday. There you go. Any other question before I log off? Yes, there is a question. Oh, they are due today. And it's not a quiz correction, the test correction. So, yeah, so you do want to turn it in today, Wednesday.
If we don't turn them in, that doesn't lower our grade, does it?
No. All right. Any other question? Well, yeah, like if you get any part correct, yeah, I should make it higher.
But not turning it in won't lower your grade, right?
Correct.
Okay.
Yeah, some of the questions were marked out wrong, but I actually already went back to it and I already gave you credit for it. So just look at it, because if you actually look at the test, I put how many points are each part. So you kind of could you do the math and you go like, if I mark something wrong, but I gave you points for it, then I gave you points for it. So it should be right.